Namaskar. Welcome to Sai Economics Point. In today's lecture, we'll discuss derivation of cost function from production function. Okay. So, suppose given a Cobb Douglas production function Q equal to a L to the power alpha and K to the power beta, and the cost function is C equal to WL plus RK. Okay. Here L shows the number of a labor, okay, and K shows the number of capital, W represents wages given to laborers, and R represents rental price of a capital. Okay, so this shows that total cost function is a function of a output. Okay, so we can write that, okay, the total cost function, the total, okay, the total cost function is a function of output q. Okay, that is c is equal to function of q. Okay, this shows that this is a constant output maximization problem with a cost constant which can be mathematically denoted as maximize q equal to a L to the power alpha k raised to beta. Okay, and subject to the cost constraint c equal to wl plus r k. Okay, see, since this is an optimization problem, we will be using the Lagrangian multiplier here to solve this, right? Now we can write the cost constant is C minus WL minus RK is equal to 0. We have to equate the cost constant is equal to 0, right? And then multiply with it the Lagrangian multiplier lambda, that is lambda into C minus WL minus RK. Okay, and will then form the composite function by adding the subjective function. Okay, so now the composite function z becomes a L to the power alpha k raised to beta plus lambda into c minus wl minus rk. Okay, now the first order condition for maximization is to find out, okay, the first derivative of the Lagrangian function, okay, z with respect to all variables, that is with respect to L, with respect to k, and with respect to lambda, and then we'll set equal to 0. So we'll get del z by del L, which is your MPL, this equal to a alpha L to the power alpha minus 1 into k to the power beta minus lambda w is equal to 0, because here k is a constant. Okay, and set it is equal to 0. So now by simplifying this equation, this becomes a into alpha L to the power alpha minus 1 into k to the power beta equal to lambda w. Now this becomes lambda equal to a alpha L to the power alpha minus 1 k to the power beta divided by w, right? And this becomes your equation number 1. Okay, now we'll get del z by del k, okay, equal to a L to the power alpha, okay, beta into k to the power beta minus 1, okay, minus lambda r, okay, and set it equal to 0. Now solving this equation, we will get this equal to a L to the power alpha beta into k to the power beta minus 1 equal to lambda r, and again solving this, we will get lambda equal to a L to the power alpha beta into k to the power beta minus 1 divided by r, and this is becomes your equation number 2. Okay, see, from equation number 1 and 2, okay, we will get lambda equal to this, and here lambda equal to this. By solving equation 1 and 2, we can write as a lambda equal to a alpha L to the power alpha minus 1 into k to the power beta, okay, divided by w, okay, equal to a L to the power alpha beta into k to the power beta minus 1 divided by r. Okay, now we can write as this equal to, okay, so this equal to a alpha L to the power alpha minus 1 into K to the power beta divided by A L to the power alpha beta into K to the power beta minus 1. So this equal to W by R. Okay. Now simplifying this equation, okay, simplifying this equation, we will get this equal to, so this becomes, see here a is cancelled, so the left is alpha by beta, okay, L to the power alpha minus 1 into L, see alpha in denominator it is plus, when it comes to here it becomes minus alpha K to the power beta, okay, into K to the power, see we can write here is minus, okay, beta minus 1, okay, so this equal to W by R. Now again solving this we will get, okay, alpha by beta, okay, into L to the power, see alpha minus 1 minus alpha, okay, into K to the power beta minus beta, okay, plus 1. This equal to W by R. Now again solving this we will get alpha alpha cancelled, here beta beta cancelled, the rest is, we can write this as alpha by beta, okay, into, okay, here K to the power 1 and L to the power here minus 1, so we'll take reciprocal of this, so this becomes K by L, okay, so this equal to W by R, okay. Now again solving this for K, okay, we'll get so K is equal to W by R into beta by alpha, okay, into L, okay. So by solving for K we'll get this value, okay. Okay, so the production function is given as Q equal to A L to the power alpha and K to the power beta, okay. We have the value of K, so now we will substitute the value of K in the production function, so we will get, so this equal to A L to the power alpha, okay, K, what the value of K, K the value is here W by R into beta by alpha into L whole raised to beta, okay. Now opening the bracket, okay, opening the bracket we will get this equal to A L to the power alpha, okay, W by R beta by alpha, okay, whole raised to beta, okay, into L to the power beta, okay. Now this equal to A L to the power here alpha and L to the power beta, okay, so we can add the exponents of L as L to the power alpha plus beta, and here we can write W by R into beta by alpha whole raised to beta, okay. So now we'll solve this equation for L, okay. So we can write as L to the power alpha plus beta equal to Q, okay, Q divided by A, okay, W by R beta by alpha whole raised to beta, and we can write this as Q by A, okay, into R by W into alpha by beta, okay, whole raised to beta. Now here L equal to Q by A, okay, multiplied by R by W into alpha by beta whole raised to beta, okay, and whole raised to 1 by alpha plus beta, because in LHS here L to the power alpha plus beta, and when it comes, when the exponents come instead of the RHS, it becomes the reciprocal of it, that is 1 by alpha plus beta. So now we can write as L is equal to Q by A of 1 by alpha plus beta, okay, into R by W into alpha by beta whole raised to beta by alpha plus beta, right. So this is the value of L, okay. So this is the value of so now this is the value of L, okay. So now substituting the value of L, okay, in equation number 3, okay, we will get, so we will put the value of L here, So now solving this, we will get, so this equal to k equal to w by r into beta by alpha. Okay, here in place of L we will put the value of this. Okay, so this becomes here q by a whole raised to 1 by alpha plus beta, okay, into r by w into alpha by beta whole raised to beta by alpha plus beta. Okay, so finally, by putting the value of a k in equation 3, okay, and solving this, okay, and solving this, we'll get the value of a k equal to q by a to the power 1 by alpha plus beta into beta by w divided by alpha r whole raised to alpha by alpha plus beta, right? And this becomes your equation number 5. Now C equal to WL plus RK. Okay, we have the value of L and we have the value of K. So we have to put the value of L and K here and just multiply the value of L with W and just multiply R, okay, with the value of K. Okay, so just we have to just write this. Okay, then opening the brackets, okay, just removing the brackets, okay, we will get this. Okay, see, q by a to the power 1 by alpha plus beta into, okay, into w is here, okay, into w to the power minus beta by alpha plus beta into r to the power beta by alpha plus beta into alpha by beta whole raised to beta by alpha plus beta, okay, plus q by a to the power 1 by alpha plus beta into r to the power 1 into r, okay, into r to the power minus alpha by alpha plus beta, okay, into w to the power alpha by alpha plus beta into beta by alpha whole raised to alpha by alpha plus beta. Okay, again solving this will get q by a to the power 1 by alpha plus beta into w by c. We have to, this is in the multiplication form, so we have to just add the exponents of w, and here we have to just add the exponent value of r. So by solving this, here we'll get w to the power 1 minus beta by alpha plus beta, r to the power beta by alpha plus beta, and here into alpha by beta whole raised to beta by alpha plus beta plus q by a whole power 1 by alpha plus beta into r, okay, into r to the power 1 minus alpha by alpha plus beta into w to the power alpha by alpha plus beta, and the same beta by alpha to whole raised to alpha by alpha plus beta. Okay, now again solving this. Okay, so again solving this equation, okay, finally we will get q by a whole power 1 by alpha plus beta into w to the power alpha by alpha plus beta, because here beta minus beta is cancelled, so the rest is w to the power alpha by alpha plus beta into r to the power beta by alpha plus beta into alpha by beta whole raised to beta by alpha plus beta plus q by a to the power 1 by alpha plus beta into r to the power alpha alpha cancel, the rest is beta by alpha plus beta into w to the power alpha by alpha plus beta beta by alpha whole raised to alpha by alpha plus beta. Okay, see, since this term q by a to the power 1 by alpha plus beta and w to the power alpha by alpha plus beta is here also, and r to the power beta by alpha plus beta, okay, these are common terms, so we can write the equation as c equal to, by taking common this term, okay, this becomes q by a to the power 1 by alpha plus beta into w to the power alpha by alpha plus beta into r to the power beta by alpha plus beta, okay, multiplied by the rest term is alpha by beta to the power beta by alpha plus beta plus beta by alpha whole raised to alpha by alpha plus beta. Okay, since say q by a to the power 1 by alpha plus beta can also be written as q to the power 1 by alpha plus beta into a by a to the power 1 by alpha plus beta. Okay, so the above equation can be rearranged and written as q c equal to q to the power 1 by alpha plus beta into w to the power alpha by alpha plus beta into r to the power beta by alpha plus beta into 1 by a to the power 1 by 1 by a whole raised to 1 by alpha plus beta into alpha by beta to the power beta by alpha plus beta plus beta by alpha whole raised to alpha by alpha plus beta. Okay, so this term we can write as q into w into r. Okay, so here the exponents 1 by alpha plus beta is common. Okay, so taking 1 by alpha plus beta exponent as common, we can write q into w to the power alpha r to the power beta whole raised to 1 by alpha plus beta. Okay, into 1 by a to the power 1 by alpha plus beta. Okay, multiplied by alpha by beta to the power beta by alpha plus beta plus beta by alpha whole raised to alpha by alpha plus beta. Okay, see, here again the exponent 1 by alpha plus beta is common, so taking is as the whole power, this again becomes the, we can write as q into w to the power alpha r to the power beta. Okay, whole raised to 1 by alpha plus beta, again the term same, and whole raised to 1 by alpha plus beta. Okay, so this is the total cost function. Okay, so after simplifying the total cost function become this, and this represents the total cost function is a function of a total output, factor prices w r, and the production function coefficient, that is a alpha and beta. Okay, so this is all about the derivation of a cost function from production function. I hope this video is helpful. If so, then please like, comment and share. Thank you. Have a nice day.